Welcome. In this video, we will explore the most severe type of power system fault, that is the symmetrical fault. We will see how it occurs, the two main types, key features, causes, effects, and the protection methods used in the practices. So before going into the deep discussion about the symmetrical fault, first, we'll see what is symmetrical fault. The first sentence he has written here, the fault which involves all the three phases is known as the symmetrical fault. Suppose we have the three phases R, Y and B. So when it involves all the three phases, then only it is called the symmetrical fault. Such type of fault remain balanced even after the fault. Suppose before pre-fault and the post-fault conditions. Suppose in the pre-fault conditions, before getting the fault occurs, suppose the current IA is flowing through this one, IB is flowing this one, and IC is flowing through this one. So after getting the fault, suppose the current IF is flowing and the IA will flow. So after getting the fault also, the same current will flow through the system. So the third point is written, the symmetrical fault mainly occur at the terminal of the generator. Suppose, let us suppose we have here the power is getting generated from here, it is getting transmitted. Here the power is getting transmitted, and this is the utilization side. So this is called the transmission side, and this is the transmission side. This is at the generation side, and this is at the utilization side. So mainly the fault occurs at the generation side. At the generation side, the resistance is higher. Resistance will be the higher. Resistance will be the lower. So current will flow higher in nature. So resistance is the lower, so current will flow the higher. That's why this type of fault is very severe in nature compared to the other types of fault. Why resistance is lower? Because when the power has been transmitted from this side, so it has passed only to this side, not even transmitted. So at this point the resistance will be lower, and if resistance will be lower, the current will be higher. So whenever the fault will occur at this point, so it will be very severe in nature. Next point that we have, the fault on the system may arise on account of the resistance of the arc between the conductors or due to the lower footing resistance. The symmetrical fault is subcategorized into line to line and line to line ground faults. So it is categorized into two types. First one is the triple LG fault and triple LG to ground fault. First and the second. We'll see the two in very deep discussion. So now we'll see here that line to line fault. So word itself only shows that, suppose word itself has line to line. Suppose this is the R, Y and B conductors. So here it is said line to fault. So all the three of the conductors getting involved in such type of faults. So either the fault can happen, suppose but it is not grounded, but it is not grounded in this type of fault. Let us suppose the fault occurs and three of them had been attached to this point, yes or no? if the tower has been fault here, and because of this one, so all of them getting fault and getting touched at this point. So such type of fault is called the line to line to line fault. So here I have written such type of fault are balanced, that is the system remains symmetrical even after the fault. Already I have told you, suppose whenever the fault occurs to the system, after fault occurs in the system is getting remain, it is not going to change. The LLL fault occurs rarely, but it is the most severe fault which involves the largest current. Already I have told you this one, it involves the largest current. The large current is used for determining the rating of the circuit breaker. Means whenever the large current which determines the rating of the circuit breaker. Here I have drawn the diagram of the LLL fault. So I have told you that this is the one conductor R, Y and B is there. So here three of the are getting and touched and it creates the fault. So such type of the fault is called the line to line fault. A line to line fault is a three-phase short circuit in which all the three-phase conductors R, Y and B are shorted together. Already I have told you, means here what is happening, in three of the conductors are getting shorted. Three of the, suppose this is the RYB, three of the conductors will get shorted, R, Y and B. Next we have next point we have that is the a very low impedance and may or may not be connected to the ground. Means it is not getting connected to the ground in the case of the line to line faults. Only the line conductors are getting involved such type of faults. So key features of the symmetrical fault. Even after the fault, the system remains perfectly symmetrical. I already have told you that whenever the fault occurs in this one, so after getting the fault, the system is getting balanced in nature only. So all the three phases are sorted and carry the equal magnitude current displaced by the 120 degree. Only the positive sequence network is used for the analysis of the such type of faults. The key, next one we have the fault is the most severe type because first it produces the high fault current of all the types of faults. It produces the highest current compared to any type of fault. Next one, it determines the short circuit rating. It determines the short circuit rating of the equipment such as the circuit breaker, bus bars and the transformers. Next one we have the occurs less frequently compared to a single line to ground or line to line fault. If you are comparing with the other types of faults like the single line to ground fault, means single line to ground fault or the line to line fault, it occurs very rarely because already we can see here, means it occurs very rarely when the three of the system is getting connected and the such type of fault occurs. Very rare, means it can be maximum 2 to 3%, means less than 10% this type of fault occurs. Next one, generally caused by the catastrophic equipment failure, severe insulation breakdown or a direct metallic short. First one, this is caused because the catastrophic equipment failure or the severe insulation breakdown or a direct metallic short at the generator site. Next one we have line to line ground fault. Here the word itself only shows that, means three lines will be there, R, Y and B, and after when getting sorted it is getting also grounded also. So such type of fault is called the line to line ground fault. Line to line ground faults. So in this system what is happening, three of the conductors are getting sorted and it is getting grounded also. So such type of the occurrence of the fault is very rare in very rare nature. A three types of fault occurs when all the three conductors R, Y and B are getting in contact with the ground simultaneously. So such type of fault is called the line to line ground fault. So I have written here, a three-phase line to ground fault includes all the three phases of the system. The line to line fault occurs between the three phases and the ground of the system. The probability of the occurrence of such type of fault is nearly 2 to 3%. It occurs very rarely in nature, and it varies from the 2 to 3%. Somewhere it is written less than 10% also the occurrence of the such type of faults. So in the diagram we can see here, we have the three conductors R, Y and B. When they have sorted and it grounded also, such type of fault is called the line to line ground fault. Next one we have the a three phase line to ground, that is L2G fault, occurs when all three phases conductors R, Y, B come into contact with the ground simultaneously. This means each phase is sorted to every other phase and to the earth at the same point. Also we have shown here that it is getting sorted at the same point only. In the diagram also I have shown here that whenever the fault occurs at the system, all of them are getting, after getting the breakage, so it touches the ground only and the here only at the same point only. The key features of this fault are, even though ground is involved, the three phases remain equal in magnitude and displaced by the 120 degree, as same as we have seen in the line to line fault. Only the positive sequence network is required for the analysis, like a pure three-phase fault. Already we have discussed in the last section also that we requires only the positive sequence network for the analysis of the three-phase fault whenever it occurs. It produces very high current, often slightly higher than a simple three-phase fault because of the earth path. It determines the short circuit MVA rating of the circuit breakers, bus bars and the transformers. Already we have discussed this point. Rare compared to the single line to ground or the double line to ground fault. It is very rare. It occurs very rarely, that we see very rarely whenever the three of the line is getting touched and the fault occurs. It occurs 2 to 3% of the system fault. Next topic that we have, this type of fault causes because of, first point, simultaneous insulation failure of all the three faults. It occurs whenever the insulation getting failure of all the three faults. Next causes we have the mechanical damage. Example, the tower collapse, severe flashover during the lightning, or the equipment explosion. Means this type of the fault occurs because when tower collapse, severe flash over during the lightning, or the equipment explosion. Next one we have that the incorrect switching or the catastrophic breaker failure because of the incorrect switching. Also this type of fault occurs in the system. The effect of these faults are complete voltage collapse at the fault point. Means already I have told you the one point is that it mainly occurs at the generation side, at the generation side, not in the transmission side, not in the utilization side. That's why this type of fault can be also called the generator fault. Next one we have the enormous short circuit current flowing through the both phases conductors and the ground return path. Because of this fault, enormous short circuit current flowing through the phases conductors and the return path. Next one we have the heavy thermal and the mechanical stress on the conductors, transformers and the generators. Next, how can it can be protected? It can be protected by the detected by the overcurrent or the differential relays that sense the symmetrical high current in the three phases. The last point that we have the high speed circuit breaker must interrupt the circuit quickly to prevent the equipment damage. So these all are the depth discussion regarding the faults. So this is the entire story from the definition through types, features, causes and the effects of the protective measures and the link with the short circuit capacity, presented in a single continuous explanation suitable for a lecture. Thank you. Welcome to my channel. So today I have a new topic, that is the effects of faults in a power system. So before going to the any further discussion about the fault, first we should know what is fault. What is fault? In an electrical power system, a fault is an abnormal condition in which current or voltage deviate from its nominal value because of unintended connections, because of the unintended connections or it can be because of the insulation failures or abnormal flow of current. So these all are the three conditions of the fault. So in simple words, we can say that a fault in any unintentional short circuit, open circuit or abnormal flow of current that disturbs the normal operational system is called the fault. Otherwise, a fault provides a low impedance path between the conductor or between a conductor and ground is called the fault. It causes the excessive current to flow or results in abnormal voltage. Faults can be of the two types. First one, that is the symmetrical, and second one we have the unsymmetrical. So symmetrical fault is always balanced in nature, but the unsymmetrical fault is unbalanced in nature. So we'll see what are the effects of the different types of faults in the power system. First point that I have written: when an electrical fault occurs, short circuit, open circuit or ground fault, it disturbs the normal operating conditions of the system. It's called the fault only, that I have discussed. Next one, that is the major effects are: first that I have written, abnormal currents. So in abnormal currents, what is happening? High magnitude fault currents flow through the equipment and transmission lines. Next we have the voltage disturbances, means severe unbalance in case of the unsymmetrical faults. Because of the faults, voltage disturbances will be there. So whenever disturbances will be there, so severe unbalance will be there in the case of the unsymmetrical faults. We have two types of faults that I already have discussed, that is the symmetrical and the unsymmetrical faults. Next one we have may lead to the over voltage surges when the fault is suddenly cleared. So whenever the voltage disturbances have been occurred and we are trying to clear the fault suddenly, so what will happen all that time? it will lead to the over voltage surges. Next one, that we have the thermal effects, because the thermal only relates to the heat only, so excessive heating damages the insulation of the cables, transformers and the generators. Whenever the fault will occur in the system, so excessive heat will produces, which can damage the insulation of the cables, transformers and the generators. Next one, whenever the thermal effects will happen, then the corrosion can happen. When the corrosion will happen, it will reduce the lifespan of the equipment or the causes the immediate failure. Means lifespan means the life of the equipments will get reduced, like the cables, transformers, generators or the insulations. Many different types of system will get damaged. Next one, that we have the mechanical stresses. In the mechanical stresses, uh, high fault currents create the strong electromagnetic forces on the bus bars and the windings. Because of the faults happens, mechanical stresses will be there. If the mechanical stresses will be there, the high fault currents will create the strong electromagnetic forces on the bus bars and the windings. Next one, it can bend, displace or even break support of the conductors. The last one, that we have the system instability. Whenever the fault occurs, system will get unstable, so generators may lose synchronism due to the sudden changes in the electrical power output. So because of the faults, system will get unstable. When the system will get unstable, then the generators may be lost the synchronization due to the sudden changes in the electrical power output. The last one, that we have, that the power system may experience loss of stability if the fault is not cleared rapidly. Means if the fault is not going to clear rapidly, then what will happen? It will may loss of the stability if the fault is not getting clear rapidly. So these all are the effects of the faults in the power system stability.